Hello, Mr. Standerson here, and in this video I want to give you an overview of main ideas around force, net force, free body diagrams. So going back to what we know about Newton's laws, is that objects in motion or at rest will continue at the same velocity until acted on by an unbalanced force. We've seen this example with the dry ice across the table, with a hockey puck as you don't have to continue applying a force for it to move at a constant velocity. All these things go back to this idea of objects in motion or at rest, stay at rest or at motion, unless acted on by unbalanced forces. So when we talk about forces that push or pull, we need a way to keep track of those. And a free body diagram or a drawing really helps us identify all the forces that might be acting on a particular object. As a physics student, one of my goals for you is to evaluate and apply this physics knowledge. So, as you're reading a problem, ask yourself, is it a constant velocity or is the motion an acceleration where you might be speeding up or slowing down? That determines how we evaluate our free body diagrams because if it is a constant velocity, we are going to look for balanced forces. If there is an acceleration, that happens because of unbalanced forces, and so one of the force arrows in the free body diagram will be larger than the other, for example. Now, how free body diagrams can help us identify this net force is when we think about net force, remember it's a combination of all the forces that cause accelerations to happen. So when we have an unbalanced force, we have a net force. If the forces are in the same direction, we'll add those together to create our net force. If the forces acting on an object are in the opposite direction, we'll subtract to find our net force. And acceleration always happens in the direction of the net force. All right, well, how does this play out when we look at a problem or an example in class? And one of the things I'm going to encourage you to do is some careful reading. For example, constant motion or constant velocity can happen when there is no net force. So an object in motion will already stay in motion. And also, when we're carefully reading things, the size of the arrow does not always tell us which direction the motion is going. So just because I look at this picture and I see the red arrow is larger, that doesn't mean the box is always moving to the left. In fact, it could be already moving to the right, and the net force is to the left, causing it to slow down. So in this case, if there's a net force, as there is in this picture, to the negative side or to the left, and the box was already moving to the right, so if the velocity was going this way, then that means that we would be slowing down because the acceleration is opposite the direction of motion. All right, well, here we go. I'm going to take a couple quick looks at this and maybe some more detail to help you out. For example, if we have these force diagrams that you can see in this picture, and there's a four different objects based on the force diagrams, which of the objects are moving to the right and speeding up? Choose all that apply. Well, I want you to carefully read that. Moving to the right means that it's already in motion and the velocity is to the right in a positive direction. Speeding up is a clue that there's an unbalanced net force, and that also is in the positive direction. When these two things are the same, positive net force and positive direction, then the acceleration will happen in that direction. All right, so which ones have a positive net force? Well, A does, so we could choose A as a best answer. All right, I see that net force right here, the larger arrow is pointing to the right. So does B. C, though, has balanced forces. Therefore, it's not speeding up or slowing down, so that one won't work. D has a net force that's pointing to the left, or a negative net force. That one won't work. And E, the forces are balanced in the vertical direction, and so it could be also moving at a constant speed, so that one won't work. All right, so going back to what we know from before, being able to decipher the words that the problem is giving you is really key in solving these problems. All right, let's do one more. Let's say we have force diagrams that are shown. This object is moving to the left already. All right, so I'm just going to mark down the velocity of this object, of all these objects, is to the left. Velocity is going that way. And the objects are slowing down. So there is a net force, unbalanced force, in the opposite direction of motion. Okay? And when we see that, we have things moving in the negative direction. That's the direction of motion. And in this case, we have a positive net force because we know it has to be opposite that motion for it to slow down. If it was in the same direction, it would speed up. So I'm going to look for something that's has a positive net force and it's slowing down, so it's going to be directed in that opposite way of the motion. All right, so let's take a look. Oh yeah, I have a positive net force. Okay, that one's bigger than this one, so A could be a good answer. All right. Also, I could say that B is, because we have a net force that's in the positive direction there. C, that one would not work because these forces are balanced. Therefore, it would be a constant velocity. So it can't be speeding up or slowing down. And D wouldn't work because this force, this unbalanced force, would actually accelerate it to the direction it's already going. So it actually speed it up instead of slowing it down. All right, so hopefully that helps. Last one, I'm going to take a look at this with you. We have an object that would be moving to the right. All right, so moving to the right. So we have a positive direction, positive velocity. All right, and it's either at a constant speed or with a changing speed. All right, so it's either going to have a balanced force or an unbalanced. Okay, so let's take a look at our options. Well, this one is unbalanced, so we could pick that because it's changing its speed. This one is moving at a constant speed, but we could pick it because that was one of the options, constant speed. This one again is balanced, so we have a constant speed, but that was one of our choices. And this is unbalanced, but it's pointing to the left. That would just cause it to slow down. That one also would work. So all of these would be answers for this question. So I'm going to ask that you go through all the questions that you are faced with and kind of ask yourself as you're going through and evaluate, is it a constant velocity or is it accelerating? And which direction is it in motion? If it has motion, which direction is it? And does it match or is it going opposite the net force direction? Hopefully this helps clarify a few things with the homework and the concept builders. Thanks and have a great day.